welcome to lesson 7 in making an augmented reality project using Unity. And in this lesson we're going to be looking at removing objects when we can no longer see the image being tracked. Okay, remember if you get any use out of any of this video, please remember to like, subscribe, leave a positive comment below, and if you have a suggestion for a future video, also leave that below. Okay, so you can see I've created a new scene using the XR environment, and I've added 4 images. So it's the same as the space, but instead I've just used some old Atari games. I've also gone to my canvas and I've made sure I've got a title box and I've got my info text. And this is where I'm going to put information for tracking, because this has taken quite a bit of tinkering. Even though the code's quite simple, it's taken a bit of faffing to make sure that it kind of works. And I want to see what I was going to. I wanted to be able to display some debug information on screen. Okay, so in my code, what I've just added is I've still got the same headers, but I've added a new one for public TMP text, and I've called it info box, making sure that I've also included the TM Pro library. Okay, nothing new down here. This is all the same. I'm still tracking the image. So again, this is what creates when it sees the image for the first time, it instantiates, it spawns our 3D model into existence. Update tracking position. This is if the object has been moved. We can't do this in the simulation, but you should be seeing a little video now where you can see that I am moving the cartridge manually. So when we're using the actual phone app, it does work. It triggers this one, so it knows that something's been moved. Now there should also be this function, which I've not included before, which is checking for has an image tracking been removed. I spent a long time with this some weeks, months ago, and it doesn't work. I found in the long run this doesn't actually trigger, so I haven't included it, so I am trying to delete it now, but that is in the tutorial from Unity itself, and it doesn't run. So I'm going to look at a different way of handling it. Okay, so I'm just going to nip back into Unity itself, because I've now got back on our XR origin. Just hide all these down a little bit, there's a lot going off. I've got because that was a public, I've got this info text, so I've just dragged info text onto our link so it knows where to talk to. Okay, the other thing I've now done is, rather than using the old reference image library, I've created a new reference image library by just create XR reference image library. So I've already done this, and I've saved it into a different folder. And this is my image reference library for now for my video game museum, and I've dragged my images on, and again, just like before, the name of this image has to also match the name of the prefab that you want to display. So the image prefab have to be the same name. If you don't want to be the same name, you'll have to write extra code for handling that. Okay, so let's go and have a look at the code. Now again, I went through this step by step. So I went up into my update function. Now you might not have got update because I didn't have it in the version that I put on GitHub last time. So I've just written it in void update. If you already have an update function, then use that one, don't duplicate it. And I've just said call function output tracking. Now this doesn't exist for you yet, but for me it does. I've already made it. I've created a little function called void output tracking. So when it does the update, which will be as fast as it possibly can, it'll link to this function, it'll call it, and I'm just saying infobox.text equals tracking data. /n just means new line, so it's like pressing the enter key. And then I'm going to loop through, so for each image that it's tracking, it's currently got a track on, we're going to display the image's name, and we're also going to say what is its current state, followed by a new line. So again, notice I have done a plus equals, so this will append, so it will add to our last line, so it'll just keep on adding these lines so you can see them all in one go. If you forget to do that, you just go equals, it will overwrite it with the final one that it reads. So it's plus equals, so to append. Okay, and that should be it now. If we just go back into our code and actually have a look at this, now press play. So I've got the canvas on the left hand side, it should overwrite that. Yep, there we go. So if you can see, it's already tracking these first two. It's picked them up straight away, and it's saying image ET is tracking and pressure cooker is tracking, which is those 2 games. But we can see there's nothing on Frogger, there's nothing on the other game, Centipede. So if I start to move the camera around, there we go, it says now tracking Frogger, and we can see it's instantiated the Frogger game screenshot. Now for this, I put a video texture onto my prefab, just to see if it would work. Now I'm not fully understanding why in the simulation the video images. That's where I want it to be, whereas in our scene setting it's behind it. I'm not going to worry about it right now. It seems to work in the simulation. Now this is the bit that doesn't seem to work very well. If I keep on turning, keep an eye on the tracking information, it says ET is limited. Pressure cooker tracking, that's fine, we'll keep on turning. So it's still saying pressure cooker is tracking even though we can't see it. And this left me experimenting for quite a while. There we go, it's now got centipede tracking. Notice though, it's only ET that says limited. So even though I keep turning round, there we go, it's picked up ET again. It never seems to lose track of the other objects. So at this point I decided, is this just because it's inside the simulation? Maybe the simulation doesn't really know what it's doing. Although as I'm doing this I'm realising that camera's never moving either. So maybe it's something just to do with the way the simulation works. So if I just stop this, I did then go to my other project where it goes to Android and test it there. So here I am in the real world. I've got the real cartridges, that's the reason why I chose to use these. And we can see it's tracking. If we look at our ET's now limited, pressure cooker's gone limited. If I move the camera over a bit more, it's gone to Frogger. Frogger's now, it's tracking. There we go. But now the other two are limited, so actually the tracking data seems to be way more accurate using the actual Android app than it would be in the simulation. So at least I know the code is functioning correctly. Okay, so I can stop that there. We'll come back in. So now I know the tracking data is fine. I just need to write some extra bit of code in so that we can do something with it, so we can hide them if we don't want to use them anymore. And again, I'm well prepared for this. I'm going to just bring a variable in, because I'm going to keep the for each loop for reasons that will become clear maybe in the future. So I'm just going to have, oops, my fingers around it. So I'm just creating a counter. I could turn this to a normal for loop, but because I've already got the for each, I'm just going to keep it there because I want to keep outputting that. What I'm now going to do is I'm just going to loop through, and I'm just going to say if the tracking is successful, if the tracking is limited, then I'm going to set this object to false. Remember, every time we instantiate an object, we are adding it to this list here. So I'm going to say if the tracking has gone limited, let's set the active to false, which effectively hides it. It's still in the memory of the computer, it's in the memory of your phone. So if you add 100, 200, 300 objects, I think it's going to have a problem. But that might be worth just testing in the future. How many objects can you track before it starts to really glitch out? So that's going to set it to false. I'm now going to do the next bit where, well, what if it's not tracking? What if the tracking is good? So if the tracking state is tracking, then set to true. This is not particularly efficient code, it's not optimized, because it means even if it already is tracking, it's going to keep setting to true over and over again. But again, this is just a way of keeping the code as simple as possible. So now, again, I'm just incrementing the I counter, so obviously it starts at 0. So if it was the very first image it came across, it will set that to false, and so on. It's just to keep a track of the loop. Okay, so this should now start to hide objects. Now we know in the simulation it's only going to work potentially on the ET thing. So I'm coming back over to Unity. Okay, so in Unity I'm going to press play again. It should still display the information on the canvas. And it should all start to hide things. So again, we've not got Frogger yet, but let's have a look at Frogger. Oops, I'm turning the wrong camera. Let's go on the right camera, show you the correct camera. Okay, so we've now got Frogger, it's tracking. So what we're going to do is keep our eye on the ET video, or sorry, the ET image on this screen as I slowly turn that screen. There we go, we can see it's now hidden. Frogger is still, zoom out a bit, Frogger's still there, let's keep moving around. Okay, we've got centipede, so it still knows ET is limited, we can still see ET is not there. Pressure cooker's there, ET's back on tracking, so it's now come back again. So there we go, we can see it's appearing and disappearing. Okay, let's just compare that to the real world one. So again, I've converted that code over to Android as well. So when I press play, we can see that it has tracked on the ET, and if I move the cartridge, this is updating the tracking updated, and we saw that it disappeared as it went off camera. So we can see it's deleted it, it's lost tracking. Bring Frogger in, it is struggling a little bit because the way my lighting's coming down. So yeah, so it's now got Frogger again. If I move the Frogger around, we can see the tracking's working just fine. We can see it disappeared, centipede reappeared. If I move the camera off, we should see, there we go, it's gone. So it's removing the objects that we are no longer tracking, which is exactly what we were after. Okay, so I think that concludes lesson 7, how we can now make our our code again as simple as possible. There's much more elegant ways of programming it, making it fully object oriented. Maybe use different image reference libraries if you're trying to handle many different 3D models, but we'll maybe look into that in the future depending how far this goes. So again, if you found this useful, please do remember to subscribe, like it, positive comment below, and again, I welcome suggestions for future videos. Hopefully in the very near future I will be showing you how to convert this to a proper Android app. Unfortunately I don't have a Mac or an iPhone, so I can't look through the process of that, but I'm open to sponsorship if anyone wants to help out with that. And I shall see you in the next one.